Hello there you beautiful people, and welcome to this video where you're going to be learning about wildcards. Now, other than having an awesome name, wildcards are very useful tools that will make your commands a lot more precise, a lot more expressive, and a lot more powerful. Now, in this lecture you're going to learn about the most common types of wildcards, and you'll see how they can be very useful for manipulating files in Linux. And by the end of the video you'll know how to use some of the most common types of wildcards, and you will also have the ability to create more powerful commands. So let's go ahead and get right into it. Okay, so first let's take a look again at the ls command. Now the ls command will list the contents of every directory that we give it a valid path to. So for example, let's say we wanted to list the contents of our documents directory. We could do ls and then give it a path to our documents directory. Okay, so we'd use the slash and then maybe we'd throw in a bit of tab completion and get it to list out our documents. Or if we're already in our home folder, like we are now, as you can see, we could just say list out documents, and that'll do fine. But what if we wanted to have a look at what's inside our documents folder, our downloads folder, and our pictures folder at the same time? Well, let's clear the screen. The way we do that is we just say ls, then documents, bit of cheeky tab auto-completion, downloads, bit of cheeky tab auto-completion, and some pictures with a bit of cheeky tab auto-completion. And then if we go ahead and press enter now, you'll see that we can actually see the contents of each directory are listed. So far, so good. But you can see how manual of a process this was, right? We had to type out documents, then type out downloads, and then type out pictures, even with tab auto-completion, in order to pass them as command line arguments to the ls command. Now, wildcards are basically special symbols that the shell interprets to have a special meaning. The idea behind wildcards is to build up powerful patterns known as regular expressions, so that instead of typing out every command line argument manually, you can instead say something like, hey Linux, make this command act on anything that matches this pattern. The patterns are known as regular expressions, and you can think of wildcards as being some of the useful building blocks for creating regular expressions. Now, using wildcards to build regular expressions gives you lots of flexibility and control over how your commands work, and can save you a whole bunch of typing. And using regular expressions makes your commands a lot more expressive. So for example, instead of expressing the ls command, like list out the contents of this folder and this folder and this folder, which is the way that we would usually be using it with command line arguments, right? We'd be saying ls do documents and downloads and pictures, downloads and pictures, okay? That's how it works like that. You've got to list them out manually. Instead, you could just do something like, hey, why don't you just list out the contents of every file that starts with the letter D? For example. Or if you're removing files, instead of saying remove this file and this file and this file, you can say remove every file in this folder as long as its name ends in .txt, for example. Or if you're copying files, instead of saying copy this file and this file and this file, you can say copy every file from this folder and this to this other folder as long as its name ends with .pdf. Okay, so now that we understand that we're using wildcards to build these patterns, these regular expressions, let's start building some regular expressions using wildcards. Now, one of the most used wildcards is the asterisk or the star wildcard. Now, I find the star by pressing Shift and 8 on my keyboard. So if I press Shift and 8, I get this star come up. If you ever use Microsoft Excel or a software spreadsheet package, it's the symbol you use to do multiplication, but I find it using Shift and 8 on my keyboard. It might be different on yours, but it's that symbol we're looking for. Now, wildcards each match a specific pattern, and the asterisk or the star wildcard matches any piece of text, regardless of the length of that text, and it also matches numbers. So let's say that we wanted to check the contents of every directory in the home folder. Let me clear the screen. If I clear the screen, instead of listing them all out, okay, because there's quite a few folders in here, right? Instead of saying, okay, ls desktop and documents and downloads and so on, all we have to do is just do ls star. Okay, so if I do that, you can see that it has just listed out all of the contents of the home folder, the desktop, documents, downloads, music, pictures, public, templates, and videos all in one go. So let me clear the screen. Okay. So how did that happen? The reason that happened is because the star matches anything. Okay, so what you need to think of is when you give a command a regular expression to work with, imagine it putting as command line arguments anything that matches that pattern. Okay, so because the star wildcard matches anything, it put everything as command line arguments to the ls command. Does that make sense? Let's take another example. Okay, so let's say I just wanted to list out the contents of the folders starting with D. So the desktop, downloads, and documents folders. Okay, what I could do is I could say, okay, let's do ls, then a capital D, and then a star. Now, the pattern is this bit. Okay, the pattern is the D, then the star. Okay, and the star is one of the building blocks, but so is the letter D. So what we're saying here is list out, then giving it as a command argument, anything that has a D, a capital D, and then followed by anything. So basically anything that starts with a capital D. So if I do that, you can see that we just see the desktop, documents, and downloads. And you can see that they all match this pattern, this D star. They start with a capital D and then are followed by anything. They start with a capital D and then are followed by anything. What if we just want documents and downloads? Well, they start with DO and then are followed by anything, right? So if I do ls, DO, then anything, you can see we just get documents and downloads, but desktop is ignored. Now, something that is important to remember here is that these wildcards and these regular expressions are case sensitive. So if we did ls, D, and then a star, notice how the D is lowercase, you can see that we get nothing. Nothing comes back because nothing starts with a lowercase d. But if we do capital D, now that will work. Okay, so that's really awesome. Let me just clear the screen. You've seen a few ways that the star wildcard can be used to match any text, and you've seen some ways that it can be used to build regular expressions. Now, there are a few other common wildcards that you'll likely use when working with regular expressions and wildcards, and the first is the question mark wildcard. Now, the star wildcard will match anything regardless of length. So, for example, if I do something like star.txt, that could match anything as long as it ends in .txt. Okay, so if I do ls star.txt, you'll see that we only see things that end in .txt. Now, it doesn't matter if what at the beginning that comes before .txt is one letter long, one number long, or 100 letters long, or is full of numbers or whatever. It doesn't matter if it's 1,000 characters long. It'll still match because the star matches anything. But the question mark wildcard will only match one place. So if I do question mark.txt, okay, if I do ls now, nothing will actually show up, okay? Because the question mark, this says, basically what this says is, show anything that ends in .txt but only has one thing before it, okay? So this would match things like a.txt, or q.txt, or l.txt, or 1.txt, okay? You notice how they've all just got one place just before the .txt. Okay, the question mark is a way of saying it's like a placeholder for just that place, whereas the star, it doesn't matter how long it is. Okay, so the question mark wildcard allows you to maintain the generality of the star wildcard because it doesn't matter what it matches. It could match a number or it could match a letter, but it allows you to limit the length. Okay, the star doesn't put a limit on length. Whereas the question mark does, but it doesn't really matter what fills that place. Okay. Now you'd usually use the question mark wildcard when you want to build a general pattern, but care about the length of the file name. Okay. So if we did something like question mark .pdf, then that would match things like a1.pdf or b2.pdf or ha.pdf or z7.pdf or something like 77.pdf. You see how we're just taking up two spaces and then .pdf? That's what question mark.pdf would do. Okay, we're saying we're going to fill it with two things, two spaces. We're not sure what's going to go there, but there's got to be two spaces, two places, and then .pdf. Okay, so that's how that works. Okay, that's the question mark. Now, another type of wildcard is the square brackets, which are these ones here, these square brackets here. Okay. Now, the square brackets wildcard is similar to the question mark in that it will only match one place, but instead of matching anything like the question mark will, square brackets allow only allow the pattern to be, they allow it to be more specific and only match the letters or numbers if they belong to a given set of options. Probably a bit easier for me to show you than to explain. Okay, so let's say we had 6 files. We had file A.txt, we had file B.txt, we had file C.txt, and we had file 1.txt, file 2.txt, and file 3.txt. Okay, which hint hint, if I do an ls, we actually already have those in our home directory. Okay, so let's say we wanted to match the files that just had numbers in the file name. Okay, so file 1.txt, file 2.txt, and file 3.txt, but we don't want the ones that have A, B, and C. Okay, to do this, we could do ls, then file, because the name's got to start with file, then open the square brackets and give it a bunch of options. We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.txt. Okay, so what's this? Basically, everything in these square brackets is an option that could fill that one place. So anything that goes file, and then either 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0, any one of those, then .txt. Okay, so if we do that, you see that we get file 1, file 2, and file 3, but we don't get the A, B, and C because they're not part of the options, right? From our given set of files, that just matches file 1, file 2, and file 3. Now, but what I want you to notice is how this wouldn't be possible using either the star wildcard or the question mark wildcard. If we do ls file question mark.txt, the question mark will match anything, okay, but only one place. If we do the star, you're going to get, oh, I need to ls it, you're going to get basically the same thing as well, because these don't restrict what goes in that place. The star will have anything regardless of length. The question mark will need just one place, but it doesn't care what fills it. The square brackets also only have one place, but they allow you to restrict what goes there. So they're like the most restricted. It's like a very restrictive kind of wildcard. Now, you may have noticed that typing out all these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is a bit of a hassle, right? So the shell makes it a bit easier for us. We've got a shortcut. We can just do file 0 to 9. And that gives us exactly the same thing. So instead of having to type out all the numbers, it's much easier, which is really useful for when you want to work with the alphabet and you can go A to Z, and that will work perfectly. Okay. What if you want to match 2 digits? Okay, so what if you wanted something like file 11? Okay, how would I do that? Well, the way you'd do that is you'd say ls file, then for the first digit 0 to 9, then just give it another digit 0 to 9, then .txt. Okay, so this one becomes the first digit, this one becomes the second digit. What if I wanted to have a number and then a letter? Well, that's easy. Just change that to letters. What if I wanted to have a number, then a letter, then a lowercase letter? Well, that's simple. Just change that like that. And you can see now we're going to have file, then one space, which can have the numbers 0 to 9, then another space, which can have the letters A to Z in uppercase, then another space, which can have the letters A to Z in lowercase, and then ends in .txt. So you can see just how powerful these regular expressions can become just by adding a few simple wildcards. We could also, what if we wanted to have the numbers 0 to 9, but also the letters A, B, and C? You can do that as well, just like that, and that's going to show up exactly what you'd expect. Anything that has the word file, then one of the numbers from 0 to 9, or the letters A, B, and C in uppercase, then .txt. If I reduce that to lowercase, A, B, C, now we'll just get file 1, 2, and 3 because these wildcards and these regular expressions are case sensitive. So you can see wildcards are really, really powerful stuff, guys. And the only 3 that you really need to know are the star, which matches anything, the question mark, which matches anything but only for one place, and the square brackets, which allow you to match just one place, but they also allow you to define what matches. Okay, so that's enough wildcard goodness for now. Wildcards can make your commands a lot more expressive and give you much greater control over how the commands work. And using wildcards in this way to search for file names actually has a funny name. and it's called globbing. So if you ever hear the word globbing floating around, it just means using wildcards to look for file names, just like we've done in this video. So before closing out, let's take a quick recap of what we've learned. First, you learned about the concept of regular expressions, and regular expressions are basically patterns that a piece of text needs to match. Okay, and anything that matches that pattern will be passed as a command line argument to the command. Now, the star wildcard matches anything, regardless of length. The question mark matches anything, but just for one place. And the square brackets match just one place, but allow you to specify options that, will actually be matched. So unlike the star and the question mark, which will match anything, the square brackets allows you to choose what will be matched. And of course, you can just type letters and numbers in that you want specifically to appear as well. So if I did capital D, then star, that means anything that starts with a D and then has anything afterwards. So you can type letters and numbers in there as well. You don't just have to only use the star, question mark, and square brackets. Okay, so with wildcards understood, you now have a very solid foundation for learning about the different ways to manipulate files in the file system. Now, each of the commands to create, delete, move, copy and paste files and so on is actually rather simple. And when you learn them, you might wonder what's the point of actually learning how to use them instead of just pointing and clicking. But by knowing how to use these commands along with wildcards, you'll be able to manipulate hundreds of files at once and with complete control, to the point that pointing and clicking will soon seem like a very slow and sluggish way of doing things, believe me. So up next, you're going to have a quick quiz to help you cement your understanding of wildcards, because, practice makes perfect. And then in the next video, you're going to learn how to create files and directories using some new commands. And you're also going to combine those commands with wildcards to make them even more powerful. You'll even learn about how something called brace expansion, which will show you how you can create 3 folders with 100 files in each of them using just 1 or 2 commands. Don't believe me? Well, I guess I'll see you in the next video.